How's it going? It's Mr. Wickens, and I'm tired, but I'm still going to make this video. So, let's recap what we talked about yesterday. Let's go over what we're going to talk about tomorrow, which is probably today when you're watching it, and then I'll give you some examples and a challenge problem. And then I'm going to eat some dinner because I am hungry. So, we started with equations, right? What is an equation? Well, has to do with that equal sign. It is an expression, two expressions on either side of an equal sign. That's what an equation is. So, we had some fun playing around with this. We started maybe with some random things on either side, but this has to be true. It has to make sure that whatever's on the left side is the same thing as what's on the right side. So I'll put maybe a 5 right there, because 2 plus 3 is 5. I could have put something else. I could have put 6 minus 1, or something like that. Then what we did is we started to look at variables. So if I have some variable in this equation, let's say I put a variable right here with an x or something like that, x plus 3 is equal to 6 minus 1. I know that I just replaced the number 2 right there with a variable x. So I know that x has to have the value of 2, because 2 plus 3 would be 6 minus 1, or in other words, I'll make this 5 again. I know that x has to be the number 2. If I think about something else, like let's say I think about, let's make up a random equation. Let's say 15 is equal to m plus 5. What does m have to be here? We have an equal sign right here, and this has to be the exact same thing as this side. It was easy when we just had numbers, because when I had 1 plus 1 equals 2, well, everything is there as it should be. But when I have a variable, I have to think, what number should that variable be in order to make sure that this equal sign stays true? Well, if I had 10 plus 5, that would be 15. So by thinking about that, I realized that m has to be 10 right there. Now, that's kind of what we talked about yesterday. Or today, I should say. It's silly that you'll be watching it tomorrow, but then after that material, what we'll be looking at is how to, rather than kind of guessing and just looking at the equation, how to properly figure out what the variable has to be. So if I take, why don't I look at the one I just did, which is 15 is equal to m plus 5. Now, because we can do whatever we want to this equation, I can add in 1, but then I have to make sure that the same thing's happening on this side. I can do whatever I want to this equation. Because I'm allowed to do whatever I want, I can actually get rid of the things around m, in other words, isolate m, to end up with something that looks like this, where the equation just tells me exactly what m is equal to. I'll show you what I mean. And this is called isolating for the variable. So, right here I can do whatever I want. Well, what I'm going to do on this side is I'm going to take away 5. But I've changed this side, so I have to change this side to make sure that this is equal to the same thing. So on this side I'm going to take away 5 as well. Now, it's kind of annoying to write it over here, so I wrote it underneath. I could, if I wanted, I could have erased it and gone 15 minus 5 like that, as long as I've subtracted both 5 on both sides. Now, what I want to do is I want to rewrite it, cleaning it up a little bit, and we'll see when I do that, well, what is plus 5 minus 5? If we think about the unit we just did, you could think about integer pairs, or you could just see that 5 minus 5 is just going to be 0. So, I'm just going to have m on this side, because that 5 minus 5 is going to get rid of itself. And then on this side, 15 minus 5 is going to give me 10. Oh, so m has to be 10. in this original equation of m plus 5 is equal to 15. So this step-by-step process told me exactly what m had to be. And by isolating m, I was able, to see exactly what it had to be. And the technique in the way of thinking about what to do in order to isolate m is to do the opposite of the things that are around m. Because we're adding 5, so I subtracted 5. So I'll give you some questions to try. And then in a couple seconds, I'll give you the answer. So I'll put some questions up, pause the video, try them out, and then once you've tried them a little bit, you can unpause it and you can see me give you the answers. So try these questions. Try figuring out what value the variables are. So x plus 6 is equal to 15. That's one. 32 is equal to p minus 5. That's another one. And then we can go 8 is equal to 5 minus a. So pause the video, try those, and when you're ready, you can unpause it. So, hopefully you've tried those out now. For the first one, I want to isolate x, so I'm going to, I'll rewrite these in a minute. For the first one, I want to isolate x, so I'm going to get rid of the things that are around x. Again, I can do whatever I want to the equation, so I'll write it underneath, as if I was writing it on the left side. I will take away 6 here, and I'll take away 6 on the right side as well, because whatever I do to this side, I need to make sure that this side, the same thing happens to it so that the equal sign stays true. Well, positive 6, take away 6, that's just going to give me 0. So I'm going to have x is equal to 15 minus 6. So that means that x is 15 minus 6 is 9. And what I can do is take this value of x, and to see if this is correct, I can actually put it back into that equation. So if I put x equals 9 into here, I would see that if x was 9, I would have 9 plus 6. Does that equal 15? Oh, yes it does. 9 plus 6 does equal 15, so that's the correct answer. So that's a good way to check to make sure your calculations are correct. Alright, what was the next one? The next one was, this blue marker is running out of juice. I'll have to get some new ones. 32 is equal to p minus 5. Well, I want to get p all by itself. What can I do? Is I can do whatever I want to both sides of the equation as long as it remains true. So I'm taking away 5. Well, I'm going to add 5 to this side. And on this side, I'm going to add 5 as well, and I'll write it this way. 32 plus 5, like that. If I take away 5 and then I add 5, I'm $5 in debt, and then I'm given $5, I make $5. Well, that's just going to be 0. So on this side, I'm just going to have p. And on this side, I'm going to have 32 plus 5, which is 37. So that's the answer for that one. For the last one, I have 8 is equal to 5 minus a. And this one's a really tricky one. Because before, I've been adding and subtracting numbers to get the variable all by itself. But here I have minus a. Here's a trick. What I want to do is I want to have a is equal to something. That's what I want to do. I want to isolate just a, not negative a, because this is 5 minus a. So watch this. What I'm going to do is I'm going to add a to both sides. A is just a number. I can add that. Now I've added a to this side. The equation sign, this is not true anymore. I need to add a to this side as well. Now, whatever a is, I'm taking away a certain amount, but I'm adding it back. I'm a certain amount of dollars in debt, and then I make that exact same amount of money. How much money do I have? Well, or how much money do I owe? Nothing. That's all 0 now. So what I have is a plus 8 is equal to 5. Ah, and now I have one like before. I can take away 8 from both sides and get positive 8 minus 8 is going to give me 0, so I'll have a is equal to 5 take away 8. And that's the tricky question. What is 5 take away 8? Well, you can use integer chips or you can use a number line again, but what we'll end up with is a is equal to -3. And you can put that back into here, into this original equation of 8 equals 5 minus a, and if you put -3 into there, you'll see that that gives you 8. So, that is isolating a variable by doing the opposite operations, and that's everything for this lesson. I also need to get a better way to erase this whiteboard, but if you'd like a challenge, here's a challenge question. Find the value of x, the variable here, in this equation. X plus a is equal to b. What? Mr. Wickens, you put 3 letters on there. I don't see any numbers. Well, I'm asking you to find what does x equal. A could be a number, and b could be a number. If I was asking you to find what the value of x is here, you wouldn't have any trouble. You'd say, oh, that's 3. Maybe you'd go and take away 5 on both sides and get that x is equal to 8 minus 5. But in this one, what does x equal? If a and b are some random numbers. It's a challenge. Think about it. And now it's time for me to eat my dinner.